graphing another absolute value function, and again k of x is an entire function inside absolute value, so I am just going to graph 4x minus 5 and flip the part that's below the x-axis over the x-axis, because that's what absolute value does to a graph. So first off, if I was just going to graph 4 to the x without this minus 5, the horizontal asymptote would be 0 because it's an exponential function. But the minus 5 is going to shift it down 5. So 4x minus 5 is going to have a horizontal asymptote right here. On the left side at least. On the right side it's going to explode upward. So I'm going to pick a few x values and just find what the y values are. So if x is 0, I get 1 minus 5, that's negative 4. So at 0, we're at negative 4. If x is 1, we have 4 minus 5, that's negative 1. If x is 2, we have 16 minus 5, well that's 11. So 16 minus 5 is 11, that's going to be way up here somewhere, so it's off my graph. So 4x minus 5 will look like this thing right here. It goes up like this, and it goes way, way, way up like that. Okay, exponential function. What's going to happen when you take the so this is not k of x. This is 4x minus 5. The absolute value of 4x minus 5 is going to look the same on this side because the y values are all positive, so the absolute value does not do anything up to this point right here. And then it's going to reflect the negative part over the x-axis. So instead of being negative 1 here, it's going to be positive 1. Instead of being negative 4 here, it's going to be positive 4. And instead of having a horizontal asymptote at negative 5, this is going to have a horizontal asymptote at positive 5. So this bounces off like this and goes back this way. So that is what the absolute value of 4x minus 5 looks like. It turns all the negative y values positive. And there you are.